All right, perfect. Thanks everyone for joining. We are super excited to have you all. This is going to be our first actually workshop ever hold. So me and really like waiting for this time to come, and today is the time. Um, so to start, what we are going to do today, you see my screen, right? Perfect. Well, I cannot hear you, but I hope all is clear. To start, let me, myself and Hussein, introduce ourselves, and we'll see. My name is Amir. I'm co-founder and CEO at Onbody, and I mainly focus on basically anything that Hussein don't do, mainly non-technical stuff, but I do also help with development. We started Onbody a bit like about a year ago together, and here we are. I'm really excited to have you all here. Looking forward to it. Hussein?
Hey everyone, I'm Hussein, co-founder and CTO at Onbody. Very excited to have you all here.
Perfect. To start, let me walk you through what we are going to talk about today. And by the way, we are going to try to keep this as casual and as relaxed as possible. So please feel free to join in the conversation. If you have any questions, please don't hesitate to ask. We do have a Q&A in two Q&A, but yeah, between if you have any questions or if anything is not clear enough, please raise the question and happy to answer. We will be starting by a quick introduction to Onbody. We will tell you a bit what Onbody is, what problem we solve, and how we solve it. And then we show you the demo of the output of this workshop, the desired outcome of the workshop, which is going to be an AI assistant app. We quickly show you a demo of that app. And then the workshop is split into two parts. The first part, we are going to build and implement what we demoed you, this application, this AI application, without going too much into the woods and to the technical details. So that will be for part one. Afterwards, we will have a Q&A and then a break for 10 minutes. And then we go with part two, which is a bit more advanced, and we will go behind the scene and we'll show you how, for example, some of the utilities or functionalities are added using Onbody TypeScript SDK. Onbody. The idea behind Onbody is that me and Hussein both coming from the web development background. For us, it's been always like a big challenge to find our way into the AI world, especially when we started about 5 years ago with making some NLP projects. It took us a long way and long journey, and still the AI part is a complex for most of the web developers or any other developers engineers outside the scope of AI. So with Onbody, we want to make this easier. We want to make it to become one comprehensive API that you need to build any AI native applications. The problem that we are particularly solving here is the fact that AI tool chain and AI ecosystem in general, the development process of it is too complicated. Currently, if you want to build a quick and simple chatbot that, for example, works on PDFs that you have on Google Drive or Dropbox, this is like a tech stack you need to put together. A lot of different fragmented pieces and modules and framework you need to put together. You need to also know probably Python as well, and it's quite of a challenge, to be honest. So in Onbody, we try to simplify this process. We build a two-layer or three-layer solutions. It's that to automate this entire AI development pipeline. In first layer, what you do with Onbody, you say you connect your data to Onbody. You say, okay, my data is in Google Drive. My data is on Slack, on GitHub, on Dropbox, and it can be in any format: PDF, video, audio, images. Once that data is connected to Onbody, then you can also select your AI stack. So for example, you can say, okay, this particular text vectorizer I want to use from OpenAI or from Cohere or an open source model. And the same for images, multimodal searches, and also a couple of other AI features that we have. Once you have this setup ready in few clicks and few minutes, then you can start already interacting with the API that Onbody exposed via a GraphQL endpoint, but also an SDK, the JavaScript or TypeScript SDK. And that's the SDK we are going to basically use today to show you how to build this AI native app. As for the demo, Hussein is going to now share the screen and show you the demo that we have, and we take it from there. Hussein, there you go.
Sorry, just a sec. So can you all see my screen? Okay, then. So this is the app we are going to build today. The data here is coming from a folder on our Google Drive, which is connected to Onbody. And you can see here the folders.
Sorry, just to interrupt, just to give you a bit of a context. So this is an AI assistant, AI study assistant, right? That basically one student can use for as an assistant for their study. We assume that, for example, the student have one Google Drive folder, and on this Google Drive folder, for each assignment or project or subject, they create a folder, and each of those folders, they put any relevant study material, from PDFs to text to audios, videos, images, presentation files, and that's the folder we have at the moment. Sorry, Hussein, go ahead.
Yeah, thanks. So there's a search bar here. You can perform semantic search here. So if we search about anxiety, it's gonna the anxiety folder is gonna show up here with the files inside it, and it's gonna, since it's semantic search, it's gonna also return results that are related to anxiety somehow. And then you can enter a prompt here to search out with your data. So let's say, for example, it is the cycle of anxiety. And the folder we selected in the previous step is going to be used as the context to generate these results. And let's ask another question. How does avoidance maintain anxiety in the long run?
Great, thank you, Hussein. So in general, let me share my screen and take it from here. Okay, cool. So as you saw that the app, the assistant app, is quite simple and straightforward. It has two main parts. One part is basically the search, where the user or student can search for relevant terms and concepts, and then as a result, they will get a list of folders or files related to that. And then among those search results, they can select one or multiple files to create a context and based on that context, they can enter into a chat, and therefore they can start a chat with that. So 2 levels that the application has. Now let's start with part 1. Sorry, before we start the part 1, if there is any question, just want to make sure. I also don't see the questions here. So is the data I shared here from Google Drive is shared with Onbody? Yes, we do. Basically, you go through a process, basically an authorization process that we will show you in a few minutes, that you grant access to Onbody to access that data. But we only access to a particular folder that you basically select in your dashboard. And we do, yes, we need to process that data, and we store basically a copy of that data in our server. But in the privacy policy, it's been explained that how we treat that data. It's in the most secure and privacy-friendly manner, to be honest. But any question, if in that regard, I would be happy to answer in the Q&A. Probably it's the best. Cool. So the next one. Let's start by looking into the UI components that we already have made those, and they are in place. The one API, one of the components is the search bar. That's where the search input goes and triggers the search. The second one is the context panel that shows the status of the context that the user has selected or provided. This panel is basically, there is a search result that split the files into 2 basically categories. It shows the directories, but also the files. And the other one is the message input. That's basically where the chat happens. The user can send a prompt, and the response to that message, that's another UI component. So in general, we have 5 different components that we use it to build the application. In terms of the code overview and the structure of the code, Hossein, you can also probably share the code sandbox link so everyone can also look into it. And by the way, the sources, the source code is also hosted on GitHub. We will share the GitHub with the recording of this session later on to your email. But the code review, we have basically 5 key TypeScript files that each of them serve a different purpose. We have and they are all part of the API services. We have utilities, which basically keep some of the utilities that we need to, for the work. We have Onbody client, which basically that's where we create an instance of Onbody TypeScript client, the SDK. We have 2 endpoints, search endpoint and chat points, and prompts. And the search endpoints basically receives a query, a human natural language query, and then in returns, it gives us the series of files and relevant documents. And then we have the chat, and the chat as an input receives a selected files as one of the part of the context, then the prompt from the user and the history of the chat. And then in response, it gives us a response to show to the users. Let's dive a bit into the search functionality. As I explained, the search input receives a search query, and then it gives us back the series of documents or files. And the chat endpoint, however, is a bit more complex. And so what we do, the inputs, as I said, there are files, a prompt, and a chat history. Once the prompts comes in, what we do, we have a utility called parse prompt from Onbody. That's where basically we can extract the concepts from it. And once we do that, then we have basically another method called multimodal chat, and that receives 3 parameters. It receives the filter files that will be used as basically applying a var filter. So we narrow down and we select the files, and we only apply the search on top of those selected files. Then we use the search method of Onbody, which is the semantic search, a near text search, and we pass it the concept. So we also get the most relevant information or content to that particular concepts that are embedded in the user's prompt. And then based on this, we apply a generative function on top of it, which will basically require to have a prompt and the history of the chat. So based on all these three parameters, we create a response for the users. This is also very important to notice that when we talk about prompt or user query, it can be in human language, right? And in general, they can be divided in three particular categories. The first one, or the usual one, is the fact that it's a prompt, but you can also, but not all of it is about the concept, right? There is a command part and there is a concept that you can search about. So it's important that we extract these particular concepts from the prompt and not search about this entire user query, but only the concept. But it can also happen sometimes the prompt doesn't have a concept in it, and it's just basically a command. So it's also important to differentiate between these. And some of them, it's just a concept, like a movie director. There is no prompt, there is no command here. So it's important to differentiate these sort of things, and that's why we have that parse query utility function in OnBody. So now, without any further ado, we can go ahead. And Hussein, could you please then start with setting up OnBody, and then, yeah, it's all yours.
Yeah, sure. Sorry, just give me a second.
Any question meantime, we'd be happy to answer. Just out of curiosity, are there any non-developer people? So any person who doesn't code? Okay. Well, good to have you, I mean, here. Yeah, we try to keep it as simple as possible. But yeah, if anything that was confusing for you, please raise your question. Bob is asking, sometimes PDF files are very difficult to extract. Numerical data, yes. Is there an option to advance AI? Yeah, sometimes that's indeed a big challenge, depending on the type of the document. We do have some generic techniques and generic models that does the job quite well, but there are possibilities to customize the models further for cases, especially the enterprise data. So if you have a particular use case, I would be happy to discuss it later on. James is asking, is it possible to also filter files by other attributes like size through OnBody? Yes, indeed. That's exactly. If you stay for the part 2, we show the advanced filtering. That's where you can basically do any filtering based on like metadata, like create dates, size, type, etc., etc. Yeah, that's possible, and that's one of the differences that OnBody has compared to other AI APIs, that we are fully basically a comprehensive content API in first place. So you can just treat OnBody as a primary database, like any other database. Don't code hard code anymore, just low code. Perfect. Yeah, welcome, Aaron. That's great. What are the data sources I can use? Yeah, at the moment, we do have a limited number of data sources because it's only me and Hussein, and we are bootstrapping. But we are adding more, and we do have some enterprise clients who basically do have customized. We created them customized. S3 was not among them, but if you have a enterprise particular case, we will be happy to talk about that. Otherwise, there is a roadmap on our GitHub. You can create an issue, and we will see if the demand goes up. Then we definitely add S3 as well. Cool. Hossein, you ready?
Yeah, sure. Shall we start with setting up a project on OnBody?
Yes, sure, please.
So
We can't hear you, Hossein, if you're talking.
Oh, sorry. So every project on Buddy isolates your data, and you can connect multiple data sources to your project. And for each project, you can select customized AI models and their settings. So we are going to create a new project here. You can either use our presets, which are categorized by use case and from different AI families, Mistral, Cohere, and OpenAI, or self-hosted ones. On the advanced tab, you can select each one specifically. So I'm gonna use it. I'm gonna use OpenAI text vectorizer and use Cohere command R LLM model.
For this case, we are using command R in particular because it has a large, basically context window. And we are going to deal with study materials, so they can also include like large PDFs or different videos which are lengthy. So it's important to use a model that can handle that large context window. Sorry, Hossein.
Sure, thanks. So in addition to these, OnBuddy automatically does some content enhancement. It's basically RAG done on multimodal data. So for visual content, we are going to use OpenAI GPT-4o to generate. It automatically generates a caption and labels the image with their type. So, for example, whether it's a photograph or it's a diagram or a screenshot, and it also automatically extracts the text. And for textual content, we have automatic summarization, keyword extraction, meme entity extraction, and topic extraction. And here we're going to use Cohere ranker, which allows us to re-rank our search results to get the best result. So once you create a project, it's going to be initialized. Then you can connect your data sources. So for this case, we are only going to use Google Drive. After authorization, you can see a list of shared drives or your drive here and see the folders inside each. So we are going to use this folder here that we showed earlier. And when you click on initialize, it's going to go fetch all of your data, processes it, and then store it in a vector database. This may take a while based on the size of your data. But I guess we are going to use this one we made earlier, and we use it for demo. To authorize to OnBuddy, you need two things. You need a project ID, and to authorize, you also need a API key. So in the settings tab, developer settings, we can create API key here. So okay, let's let's start with the implementation. Is the font size all right here?
It's okay for me.
Okay then. So briefly looking at the structure, we have a list of components here, which were shown on the presentation. And there's a layout for the layout page. There's basically one page, the home page. And there are some query. There is a query here, use search, which is made with React query library. And the most important part here is the where we connected to Onboard, which is inside the services API. So we are going to need to install the Onboard TS client here. So once it's installed, we can initialize an instance. So I'm going to import it here. We are going to treat the API key from environment variables. Or let's just put it here.
It's also very important that when you are basically initialize the instance of Embodied, you keep it in the backend code to just make sure that your API key is not exposed in the client. You can, of course, use the client on the front end, but that means the API key will be exposed. Although it's only for it's a read-only key, but still, as a good practice, we always suggest to keep it in the backend part of your application.
Yeah, but just in this workshop, we are not going to do that to keep it simple here. So let me create another API key. And from the settings tab in the project, we can copy, find the project ID, or we can also get it from the URL. So now that it's been connected to Embody, we have the instance, we can start by building the search component here. So in the homepage component, we already have these components, but it's not connected to anything. And we're gonna need to start with creating the query. And as showed in the presentation file, we have two endpoints here. One is for search, which we are going to implement here now, and one is for chat. So let's start with search here. So we have these different file types stored in different objects in Onbody, and they are accessible with different keys in the Onbody API. So for example, for text document, we have this object. For video files, we have a different object. And so for both chatting and searching, we are going to have to implement one query per each type.
Can we do one type for the beginning? Just do, let's say, Google Docs or text documents.
Yeah, sure. So let's just start with Google Doc. Okay, we have Yambari client. So with Unbody Get, it's very similar to the GraphQL API, same names. So Unbody Get Google Doc, and then we are going to do a semantic search with this method here, search about. Here's the query. And then exit to run the query. And this is going to fetch most recent Google Docs in Unbody in your project, from your project. And payload is basically an array of those objects. And you can also select particular properties you want to fetch. So let's fetch original name for now. And actually, let's implement this for comparison for Google Doc. So we need the type name, the original name. We are going to get the auto summary, which is automatically generated by Unbody to display it on the interface, and auto keyboard, and the path of the file on Google Drive. Okay, we need to map the data type to a predefined type we have here, which is used in the entire interface. A file data has its properties, and there's a type here. It's either a folder or image or video, other types. So I'm selecting another additional field, which is the ID of the object in the database. So we need the ID here. Additional ID. The name is the original name here. So I'm gonna remove the first element in the path. It's always this, a forward slash, and the last one, which is the original name. So since we are not going to need that, I'm just going to remove it. the extension study empty. Google Docs don't have an extension. And as for the summary, it's auto summary. The type is a document. We're going to use auto keywords as tags here. And the metadata is something we use later in other endpoints to refer to the document. Okay, so now that we have this endpoint here, we need to actually it's implemented before already. It's a hook that we made with React query to use in the component. So now in the home page, we're going to need to connect this to the API. Sorry, the search component to the API. So we need to define a state for the query. Sorry. And then we need to implement a search using that use search route. So it needs a query, and I'm just going to pass some arguments here to avoid it to refresh the data every time the query changes. Now that we have, we need to implement the trigger when the user clicks on the search button. We basically need to hard refetch. For some reason, this interface here isn't working. I'm just going to open it in a new tab. So now if we say for one side here, it shows the Google Docs. One other thing we need to do is to populate directories. So on Onbody, we don't keep data for folders, but we can populate those from the data files, the data property of those file data. Sorry.
So could you, maybe this part you can just copy paste it, because that's not.
Yeah, sure. No, we already have this.
Oh, perfect.
Okay, let me check. For some reason, it's not working.
That's demo. Didn't you have to restart the page or refresh the page?
Okay, let's like this data. Oh, I missed this dependency here. So yeah, it's working.
Cool. Any questions so far? Great. Okay, let's move on. Now we are gonna basically apply the same logic that we did here for Google Doc for every different document type.
Yeah, to combine multiple queries, we can do something like this. And build the query here. And another one for text documents. And then we can use onBody exec to get the result for of these queries. So it makes one single HTTP request and resolves the data. I'm just going to copy paste the data here, the code here, sorry. So it gets the search result for all data types. Yeah, so we select a few properties for each of these document types, file types. And this is just to display it on the interface. And then we are going to limit the results for each file type to 10. And then here that transformation happens for each data type as shown before.
Sorry, Thomas has a question here. Yeah, it is possible, but then you need to basically search on the level of chunks, text blocks, image blocks, or video blocks. With that, then basically, but it's still, for example, text blocks are different than subtitle entries. So there is no way that you can target videos and text documents in one single call because they are different by nature.
Yeah, but we are working on a different solution for chunking, and it's in our roadmap. And it's probably gonna resolve that. So now that we have the search, okay, the selection is important. I'm also going to add a hook here to fetch the most recent data from somebody once we open the tab. And another one here to clear the selection state after searching for a different query. Okay, shall we start implementing the chat endpoint?
Sure. So far, what we have done is basically we implemented the search, and the users type for some keywords or a concept or whatever queries they want, and then based on that we fetch a list of relevant files from different data types: PDFs, audios, text files, which basically is PDFs, Markdown, GDocs, Google Docs, and then images, audio, video. Then we show a list of here. We also categorize them in folders. So user can either select a folder. When select a folder, all the files inside that folder will be selected, or particular files also can be selected individually. The selection part is basically to create a context for what is come next, which is the chat. If no question, then yeah, I would suggest to go ahead with the chat endpoint. So now we have the selected files, right?
Yeah.
Okay, cool.
So let's create a state for print.
Hossein, is it possible to make the file list on the left, the panel, a bit smaller, so give more space to the code?
So we can do that.
Perfect.
So here we need to use the chat endpoint. We are going to implement that later, a bit later, connecting it to the endpoint. Okay, so here we need a list of files. We are going to pass the selected files. It will be used as the context, and we need a prompt. There's a state for that, and we need history. So we need another state for history also. We're going to use this type, which has it's really simple. There's a role, assistant or user, and there's a message. Okay, this selected files was an array of IDs. We need to um, filter the files. If selected files includes that ID, and then we clear that from. Okay, there's this search component has this compact property, which we are going to enable it to hide all the hide the context panel, the files. And so if we have at least one message, it's going to be in the compact mode. So we need to add the message generated by the LLM to the list of messages here. And also user's prompt. And then we need to pass data to chat messages. So let's try. Yeah, it returns an empty message. So we need to implement the chat input. We already have built a few utilities to keep this a bit simpler, and most of these utilities, or probably a more enhanced version of them, we plan to add it to our SDK, TS Client SDK. But for this workshop, we have implemented those here. So there is this multimodal chat, which we are going to look into in the second part of the workshop. But now we are just going to use them. I'm just trying to simply return the message generated by the model. So let's try again. Okay, it's worked.
Can you try another prompt, Hussein? For example, I don't know. Let's say, tell me a joke about the main topic of these files.
Sure.
Probably this is not the best topic to make jokes about, but
Yeah, tell me a joke about the main topic. These files.
cool.
Yeah.
All right. I think this is the end of part 1, right?
Yeah.
Okay, cool. Thank you. Now you have time for Q&A. Oh, that's great. So we have a psychologist. Is the answer accurate, Bob? Cool. So yeah, so far, is there any question? Now it's the time. We have about 10 minutes to have a question answering, and then we will take a short break, and then we dive into more advanced stuff behind the scene, like how we are using advanced filtering and all those multimodal searches and generative stuff. I think that's for you.
Yeah, sure. I'm using it. Unfortunately, as it has a bad microphone quality.
Great. So it seems there is no question, I guess. Oh, right. Well, as a student, somebody might not be able to directly help you, but yeah, of course, if you're a developer, you can make such an assistant for yourself or your for fellow classmates to use it as an assistant, I guess. I would have loved to have such a thing when I was studying back then. But do you have any particular idea in mind? Cool. All right. Let's say, yeah, we are at our time, 5 p.m. Let's say 10 minutes break, and then we will be back in 10 minutes. I'm going to be staying here in case anyone has a question or anything, but otherwise, see you in 10 minutes. Thank you so much. So basically, Bob, yeah, you are asking about deployment. This is a Next.js app, so you can deploy it on various platforms like Vercel, or if you have your own servers, you can also host it and deploy it there. It's nothing different than any other Next.js app, if that answers your question. Of course, you can also run it locally, but yeah, if you want to use it for private use and personal use. But when it comes to Onbody, of course, Onbody is a cloud service, so it's you cannot run it locally. you will be just interacting with the API. Let me know if that answered your question. James, as for your question, you can basically see the progress in your dashboard. We do not have a real-time statistic at the moment that, for example, how many files is being processed at every single point in the time. However, we do it on intervals, and you can keep looking at the dashboard at the moment. And we do not have any API endpoint to receive those statistics or statuses. So the only way would be your dashboard. Oh, one more thing, James, and that's also important. The update is simultaneous. So anytime you make a change in your Google Drive or Discord, wherever, there is a buffer of 30 seconds maximum, but then within that, we already process the changes and catch the changes. Aaron, I'm not sure if I understood what exactly you mean. Hussein, do you have any answer to that?
I'm not sure either.
Maybe you can elaborate a bit. Bob, well, basically that would be out of the scope of Onbody. Of course, so I mean the data collection part, because you need to somehow give the data to Onbody in form of a spreadsheet, for example, on a Google Drive or somewhere. So you need to take care of that part yourself, meaning that receiving data from, because Onbody doesn't allow any write activity to the database. It can only read the data from existing files. So you would need to have to basically take care of the part that the receiving data from your users, store them somewhere in a spreadsheet or somewhere. Of course, in some cases, we can also open a customized gateway that you can automatically connect to Onbody using a webhook and send the data in an arbitrary format, but that would be a customized solution for you. But yeah, indeed, if you want, you can store them on a spreadsheet, host it on a Google Drive, and connect your Google Drive to Onbody. And I believe if you, for example, use Google Form already store the question answers directly on Google Drive folder in a spreadsheet. So that would be super easy, actually. Hey, Aaron. No, not really, because Zapier is also an end-to-end. So I guess you basically connect one app to another app. We do not have Zapier or app API-G integrations. We can only read it from particular sources. Google Drive, Discord, Notion, what else? GitHub, Google Calendar. We are adding more and more to the list, but I'm not really sure if Zapier is going to be ever on the roadmap. And that's mainly because you need to go through basically we need to access the data on behalf of the user, and therefore any source requires us to go through an authorization problem with them and security checks. I'm not sure how it would work with, for example, to get the data from another third party like Zapier. Yes, Bob, that's correct. Hossein, could you also share the link to GitHub? Maybe we can send it.
Sure.
We will share all the materials that you saw also with a follow-up email later on. But yeah, Hossein can also share the GitHub code. In general, if you look at the Onbody GitHub, we have all our use cases or examples on GitHub, so you can also use it. All right, cool. I think it's 10 minutes. If everyone is here, please, I don't know, show an emoji or something so we know that we can start. Whoa, that's a cool emoji, Sam, on the drawing. All right, shall we go to the next part? The next part is going to be a bit more, I would say, intensive. So let's see how it goes. Hossein, it's all yours.
Yeah, sure.
Bob, I'm not sure what you mean exactly by how it happens, but when you upload a video or audio, Onbody automatically extract or generate transcription for them automatically. So it's already there. So you can just use it. For example, you can run a semantic search on top of it, or you can do a generative search on top of it. But now Hossein is going to also show you like how to work with the chunks and like a bit more advanced stuff. Yes. Okay. Let me now start with the second part. Cool. Part two. In part two, we are going to dive into behind the scene. Hossein had this multimodal generative endpoint, if you remember, that would receive list of files, a prompt, and chat history. And based on that, it would generate one response to the person. When it comes to documents, any type of documents, being it text documents like PDF, Markdowns, or Google Docs, or be it like videos, audios, or images. When users use a prompt and ask a question or command something or do a generative search in general, when you look at all the documents, not all the documents and all the parts of each document is relevant to what user asked, right? It's the same in normal life. When we read a book, and each section of the book or each paragraph even can be related or can be about something completely different. So when you do these sort of like processes, when you do semantic search or generative search, it's important that you don't apply these if you want to have an accurate result on top of the document in general. Of course, if you have like thousands of documents, for the first level, you can definitely do on top of all the documents. But then if you want to have more in-depth answers and query responses, then you really need to dive into and then only apply the generative part to those parts of the documents that are relevant. So here we are using the same technique. What we are going to do on body, so when you look at each document, for example, a text document is built of paragraphs and images, for example, or a video is built of a series of subtitle entries or one-liners with timestamps. What is important here, what we are going to do, we have a series of files that are already filtered based on the previous steps, right? Do you remember that user would select a list of files here? And so we have these files. We know that this is the context that we are supposed to apply the chat to it. But then what we are going to do, we are going to look into each one of these files and basically grab the smaller pieces of those files, which are blocks, basically. Can be text block, image block, audio block, or video blocks. And then this is in usual called basically chunks. And then apply that semantic search with the concepts that I already told you, that we do have basically a utility that generates the concepts or extract the concepts from any sort of user query. As I explained here, for example, if, for example, user queries summarize the discussion where the future of mobility is important, and then formulate the answer in a markdown format using proper tags and elements. In this entire user query, there is only one concept that you need to do the search on top of it, not the entire prompt. And that's future of mobility, because that's the concept user is looking for, right? So we do have a module that does that. So assume that we do have that concept already. So what we are going to do, we are going to search among the smaller pieces from each of these documents. And we are going to apply the search on top of text documents, image documents, video blocks, audio blocks, etc. And then from those, we are going to take this out and only apply the prompt or ask the model to, and same time, we also provide the history of the chat and the user prompt as the extra context, and we basically draft a new prompt on top of that, and we say, hey, now based on these extracted and relevant blocks from these documents, apply this generative basically command or tasks. And in response, we will get a response based on the text and images block, right? We are going to do the exact same thing also on top of audio and video files. Why? Because they have a different type of blocks. Here we have paragraphs and images, but here we have just subtitle entries. So, and that's why we need to separate them. So we are going to do the same exactly here. We are going to apply basically the search on top of the subtitles. So we say, hey, grab all the subtitles about anxiety, right? And then put them together and now apply the new prompt, new structured prompt on top of it and generate a response. So now we have two responses, but our user requires only one response, right? We are trying to make a more human, basically, dialogue. So you cannot say, hey, I found this response based on text blocks, and I found this response based on audio and video files. Of course, you can do that, but that wouldn't be nice. So there is one extra step involved, and that's where basically we give the same prompt, and the response for the text and images and the response for audio and videos, together with the prompt of the user, we draft a new prompt, and then we send it again to the generative function, and we say, now combine this all together and give one final response. And that's the response we show to the users. I hope I didn't make it too complicated, but this is what we are going to basically now look into the code behind this diagram. Any question? So Bob is asking, where did these subtitles from the videos come from? From the video, because if the video is having an audio and there is an interview or a dialogue in it, or it's a presentation, whatever, so the transcription is automatically generated in API in Unbody. Basically, Unbody generates those. No, they are not generated by this app that we are developing. The app we are developing is going to use those generated summaries or subtitles, basically, that are already generated by Unbody. No, they are not from YouTube as well. But if you're, so what we do behind the scene, we use the Whisper model to extract those basically data. And we're also using a Mox video service behind the scene, which basically handles all those complexity for us. Oh, perfect. Cool. Now, Hussein, go ahead. It's you and the code.
Sure. So what I measured in the presentation happens in this function, which was part of this utils file. And get rid of those. Okay, so let's start with generating or extracting concepts from a prompt, where we ask the same model to analyze the user's prompt, to extract some concepts, the main concepts, and some related keywords. And so then we use that to perform semantic search. That happens here. So there is this function, parse user prompt, which uses this prompt. We have 3 prompts here. And these are just templates that we use. So this one is used for parsing user prompt, which returns concepts and related keywords. And if we go back to the multimodal chat, so we extract those keywords. This is just a little bit of validation on the LLM's output. Yeah, and since now we have the main concepts and some related keywords, we repeat those concepts to give it a bit more weight compared to the related keywords.
Just to add extra context here, so when we use the semantic search behind the scene, we are using a near text method. And near text method, you can increase the weight of your input query, which is the array of like a string array of strings, the concept. By repeating them, basically, we are creating more weight. We are giving more weight to the concepts in comparison to related keywords. That's just a little trick that we do. You can also just not repeat them and send only the concepts here with related keyword.
Yeah. Then now that we have those concepts, we're going to use them to search for chunks, text blocks or image blocks or subtitle entries extracted from video files and audio files. And that happens in these generate from files. So here we basically group files by their type name. And then we perform a generative, let me open this one, this happens here. So here's where the query is built. So for text document, we just to keep the HTTP response smaller, we just select type name.
Hossein, is there any way to make the text a bit bigger?
Yeah, sure. And just zoom here.
Yeah, it's
Is it better?
yeah.
Okay. So for each type of file, we create a different query. So for text documents, we look for text blocks that are part of those selected text documents. Those text documents could be PDF files or Markdown files or whatever. And then we use generate from many and give it that prompt. And we give it two properties here for the model to understand the data type and the content. So here we are just using HTML because if text is just plain text, but for model to have a better understanding of the data, we pass it the HTML as context. So if it's a table, then it's more structured for the model to understand.
Because also here, when we talk about text blocks, imagine a markdown file, right? Each block can have various or different types. Some of them are headings, or it can be a list item, or it can be a table, an image, etc. So when Embody create those chunks, already also extract some metadata from each of these blocks, including the tag name, HTML text, then order number, so which basically position it has in that particular document, and what else, Hossein? I don't know. Only these, I guess. And of course, the reference to its parent document, which Hossein is already here, basically filtering out.
Yeah, that happens right here. So this document refers to text document object, and we filter it based on the ID of those text document files.
Hossein,
And we do.
Sorry,
Yeah.
could you quickly show what are the where operands here? All the operation operands, if we can show them.
Yeah, let me write another one here. So Google Doc, for example. So yeah, we have top level operators and or, and we have yeah, contains all, which checks if an array contains all the values passed to this operator, contains any which we are using here. So it checks if that particular property is included in that array we are passing it to, and there's equal, greater than, yeah, for numerical values.
Thank you. Just a minute. I think, James, you asked a question about filtering. So here, and also just to show you like what type of metadata, maybe Hussein, you can also show the schema of, let's say, Google Doc, just to show what metadata we are storing, or one image. I don't know.
Yeah, sure. We can look at it here. I guess it's gonna be better. So for images, we have the alternative text title, and this is base64 encoded that can be used with image vectorizer to perform near search. So you could search for images by sending another image as input.
Size, type, height, width, extension.
Yeah, there's extension, the MIME type, the timestamps,
Cool.
and the auto-generated fields.
So basically, you can filter based on any of these metadata here too.
Yeah.
Cool.
Okay. So we do the same here for we filter text block for text blocks included in those Google Docs that the user has selected, and we do the same here. We pass it the tag name and HTML. For image blocks, we pass extracted properties and as well as the original name, alternative text, and the extension.
Sorry, again, in line number 54, what you see as a second argument, we say we pass to from many. So the first argument is the prompt, and the second one is a list of properties of that targeted entity. In this case, is image block. So in this case, we are telling the model, hey, answer to this prompt only by looking at these properties: the original name of the image block, the alt, the text, auto types, auto OCR, auto caption, and the URL. And so this is the entire knowledge basically that the model has for that particular image, and nothing else, nothing more, nothing less.
Yes, same for audio files. We look for subtitle entries and we pass the start timestamp and the end time and the text. Same here for the video. And then we perform near text on those results, on those objects side. And we give it a limit. So we get the top 50 result per each of these data types. And then this query is used here. So once we group the files by type name, we call that function for each and create that query, and then we execute those queries, and we return the generated result.
Can you also, Hussein, demonstrate just one simple full complete generate on top of a document, like, or a text block, just to see how it looks from start to end?
Yeah, sure.
Because usually it's much simpler. You don't need to, but here it's more kind of complicated because we are making it for various files. But at the end of the day, they are all the same syntax. So embody.get.text blocks, and then you say.
Yeah, sure. And also, you don't have to always do generative on data chunks with models which have a longer context window. You could also pass the whole document data. So here we can say generate from one, for example. So generate from one performs generative on each of the documents in the search result. generate from many, merges those documents and pass them to the LLM and returns a single result. So here we can pass the prompt. So for example, summarize this document, and then you could use some define a simple template here. So we say here's the content, or we could also pass the HTML or more properties, metadata properties to get a better result.
Cool.
And you can simply get the result from here. So for the first document, it would be this. This would be the result. So back to multimodal chat. Now that we have one answer per each of the file types, we need to merge those answers. And if for some reason, this is just for handling errors, if for some reason we don't have an answer, we just return a message here. And then here's where we merge those responses together. So here's another prompt. And this generate method from this utility file is used to perform a generative without any context.
But yeah, let's not explain that. It's a hacky way for now before we implement it in our backend.
Yeah. So we perform a generative and we manually pass the context here. So the context is the prompt, user prompt, and encoded responses in JSON format. So here's the prompt. It's basically the same prompt, the original prompt we use for chat, but now we pass the responses here in the prompt, and we ask the model to give the best response or generate a new one if some of them are related or some of them answers the question or the query. Okay, I think that's it. Did I miss something?
No. All good, thank you. Let's move on to the questions, if there is any. Sure. We already also have videos in there. So Hossein, could you go to the drive and quickly show the videos you have?
Yeah, sure. So we have a lecture here.
Okay, cool. And now let's say we want to particularly chat with that video. Let's go and look for that video first, select it. I think you should look for ADHD, probably. I don't know.
Yeah.
Then you can select, let's just select that particular video. Okay, and now let's chat. Let's say, okay, what is this video about? Summarize it in 3 bullet points.
Is this video in there?
No worries, Aaron. Glad that you like it. So, Bob, is that the answer to your question, or you missed the part that Hossein explained how we basically apply the RAG on top of video subtitles? So maybe, Hossein, you want to go back to the part that you are applying this on top of the video and
Yeah, so here's
well, how
screen.
well it works, yeah, I mean, you should just, yeah, maybe you can clone the repository, run it locally, but then you need to create an API key on Onbody, put some files on your Google folder, and yeah, test it for yourself. And again, depending on what model you are using or you choose in the backend, it all matters. For example, at the moment, this is Hossein with Command R, right?
Yeah, Cohere's command R.
Cohere commands are, you can go with, for example, OpenAI GPT-4o, or you can go with the command R plus. So each of them has different qualities and different behaviors. So you need to see what works the best for you. But in terms of the,
Yeah, and
I think,
sorry for
yeah, go ahead.
and for this workshop, during this workshop, you can also try it with the same material if you want to see how it works. Here's the URL. Sorry, Amir.
No worries. Great. Okay, any question or feedback also would be great to hear, because yes, this was our first workshop, to be honest, and we were quite stressed how it goes and how it would be basically perceived and accepted by you guys. But I don't know if there's anything we should improve, please feel free to also share. Great. Thank you everyone for being with us today. Thank you, James. Yeah, okay, cool. We will definitely. Yeah, let's keep in touch on social media, on LinkedIn and or X. And yeah, there will be more workshops coming, and there will be way more use cases that will be open source to use. There are also other study material and resources that you can find on the website. We would love to hear your feedback, but also if you have any idea or if you want to make something with Onbody, definitely we would love to hear from you. Get on a call, discuss it. Yes, we do also have a Discord, Bob. It should be on the website. Let me also grab the link quickly. Onbody. Our Discord is quite small, but yeah, let's see. It also grow over time, probably. Yeah, we do have a Discord as well. Great. Again, this sort of workshops and our approach and our idea in Onbody is to make the AI development easier and more accessible for anyone outside the scope of AI engineering, because sooner or later, AI native applications and AI enabled applications are going to become the dominant and standard in every sense. So we do need more developers and more web developers, more backend developers, iOS developers, Android developers to get their hands with AI, but you don't need to know everything about AI, to be honest, too, because yeah, front-end development and backend development is also expertise. So we can focus on what we are good at without worrying about too much about the AI complexity. Awesome. Thank you, everyone, and hope to see you in the next workshop. Great.
Thanks. I was just wondering, sorry, is it also possible, like when you have for example, you ask a question and gathers it from different blocks, text blocks. For example, you have 3 papers, and then the answers combined from these 3 documents.
Mhm.
It's also possible to get the references because it knows
Yes.
from which file it gathers the data. But is it also possible to
Indeed.
show it on the response?
Yeah,
For
yeah,
example, like a little footnote, like this is from source 1, source 2, and source 3.
definitely. You can. You can. So there are 2 ways to do that. Either you can do that programmatically, meaning that when you saw that when we get all the text blocks or all the image blocks, we say filter those text blocks that belongs to this particular document, right? So we already know which document that text block basically belongs to. So that's the document reference. And then within the document, you can also specify it because each of those blocks has an ID and an order. So you say, for example, okay, go to the paragraph 20. This is the reference to document A, paragraph 21, for example. And that's how you can also show it. We didn't just show it, but yeah, the data is already included.
Okay, good to know. Thanks.
Cool. Yeah, we have one example, which is it's a use case. It's called at the moment it's called Nextlog, but we are going to change the name. It's a blogging platform that we have built on top of Onbody. Let me share with you. And there you can see how we basically grab all the text blocks and then put them together to construct the document again. And we do a lot of reference